So I'm going to ask you to interact with some code during my presentation. Only a little bit though, so don't get nervous if you've never touched code before. You will need a code editor that can display line numbers. For example, we saw earlier JetBrains. I'm going to be using Visual Studio Code, which is very popular um, code editor for Mac and PC. There's also Eclipse, Notepad++, and if you have a Mac, Xcode can open up code as well. So you'll need to download a couple of files we sent in advance in a Google folder. There's an HTML file called LaTeX spelled LATEX underscore workshop underscore APH dot HTML. You'll be editing this. I'll tell you where to edit things in the HTML file, and you'll also need to open it in your browser. So I'm going to be looking at code in a code editor and also the web page on a web browser. And
Okay,
I'll repeat this again when it's time to do the tutorial. But yeah, so you'll need to download that. And if you want your HTML page to look formatted nice, you also need to download the style.css file, but you don't need to open that. It just needs to be downloaded so the web page looks pretty. So don't worry about it. But that's it. Yeah. I'll repeat
great.
that again later as well.
Thanks.
And I
Thanks.
just dropped the link to the Google Drive that has your document in there, so that should help if folks are looking for any of the links to download the softwares that she recommended for the editors or the presentation in general. Those are available in the Google Share Drive.
Awesome. Thank you very much.
You know if Stacy is
Oh, apologies. Stacy has jury duty today,
Oh,
so she will not be able to join us.
got it.
Yes, totally forgot to tell you. Yeah, she got selected for the jury. She's out for like a week and a half.
Oh my gosh. Well, okay. I
Yeah,
mean, it is the democratic process.
yeah.
Well, it's always at the worst time though. Like that
Yep.
yes, I have to say, right? They never at an ideal time for sure. So I feel
Yeah, so
like our
I will introduce her
supervisors
as
have.
well, but she won't be here.
Okay, okay.
Yeah,
Well, thank you. Well then, I mean, if we can we can get going then.
Yeah.
sounds
Um,
good.
let's see. All right, everyone. So we are halfway through. This is exciting. And we have a very interesting presentation today that you can interact with if you've downloaded the files. Otherwise, just sit back and enjoy. We are recording this, so you can always go back and look at it later as well once we get that posted to our YouTube channel. But I am going to just hand it over to our, let's see, LaTeX in HTML teaching session presented by, well, Dr. Stacy Branham and in in uh, in
And team.
and team, but Isabella Ferreira. I'm sorry, did I say that right?
Figueira.
Figueira.
Yeah, Figueira. Thank you.
Sorry about
Okay,
that. Go
no
for it.
worries. I'll share my screen. Thank you so much for introducing us. Can you all see some slides?
Yes.
Great. All right. Hi, everyone. My name is Isabella Figueira, and I was supposed to have my co-presenter here, Dr. Stacy Brenham, but she is in jury duty, so she won't be able to join us today. Today, we're talking about an introduction to LaTeX math equations and computational thinking in HTML. Really excited to talk to you all today. So that's me. I'm Isabella. I got my bachelor's and master's in computer science at a couple different universities. I got my bachelor's at Santa Clara University and my master's at UC Irvine, where I'm currently a PhD student in informatics. That's the study of technology and society, in case no one knows what that means. And I put a blurb on the slide. I wrote, I'm passionate about computing, education, accessibility, and equity for underrepresented students. So my research is all about how can we make computer science education for high school students and college students more accessible for like blind and low vision students specifically. That's my whole thing. And I also put some links to like, I have a little website that I made for myself and also my LinkedIn and Blue Sky in case you want to connect with me. And this is Dr. Stacy Brenham. She is my advisor. So I work with her closely on my research. She got a BS, a bachelor's in science in computer science at Virginia Tech. She also earned her PhD in computer science slash HCI, which is human computer interaction at Virginia Tech. She was then a postdoc and a lecturer at UMBC. And currently, she is an associate professor of informatics at UC Irvine. In her blurb, she wrote, I'm a woman with a disability in computing on a mission to empower students with disabilities and educators across the country to make computing, STEM, and higher education accessible to all. And today, I also have one of my lab mates here with me today since I have a cold and maybe my voice is going to disappear in the next hour. So I have her here today. Her name is Josa. Do you want to briefly introduce yourself since you don't get a slide?
Yeah. Hi, everyone. I'm Josa. As Isabella mentioned, I'm also part of the same research lab as with Professor Banham and Isabella, and my work is also in the educational space. And specifically, I am currently studying the accessibility of STEM camps, specifically summer camps, and just seeing how those essentially shape the transition for high school students who are disabled into college. So it's very nice to be with you today.
Thanks, Josa.
Mhm.
All right. So today in this workshop, we're gonna be toying with LaTeX math equations in HTML. So some learning objectives include recognizing how math accessibility impacts CS education in college. We're gonna learn how to write basic LaTeX expressions for math notation, and we're going to understand the connection between LaTeX math and computational thinking. So why are we talking about digital math in the first place? So we've been learning in my research that blind screen reader users in higher level math courses in college sometimes find themselves at a crossroads when it comes to accessing their math materials like textbooks. Braille is typically their tried and true math format, but in college, materials can take so long to get printed that students might fail their classes. So digital math might be an option for students to gain faster access to their math courses. Some students weigh using Braille or switching to digital formats. For example, one student might think in their heads, should I wait for my trusted Braille materials that could arrive after a due date, but I could fail the assignment, I could fail the class. On the flip side, they might think, should I learn a new digital format for reading and writing math? But that requires more work to learn new symbols, and math is already so hard. Both Braille and digital math have pros and cons. Although it requires more learning, LaTeX is a great option for reading and writing digital math. And we are learning that digital math formats are an opportunity for students in STEM to read and write math more quickly and accessibly. In our work, we've spoken with several blind STEM students in college who swear by reading and writing math in LaTeX. One college student we've talked to, who was a third-year computer science major, learned LaTeX before starting college to avoid Braille printing delays. And he said that LaTeX made it easier and faster for him to read math. Like think calculus and linear algebra, all of those like higher level advanced math classes in a computer science major. Another student named Campbell, who is a math major at Harvard, told us that LaTeX was her format of choice, even calling it a gold standard. I'll play you a clip of her participating in a panel at one of our STEM outreach events here at UC Irvine. Oh, wait, I don't think I shared my screen with audio. One moment, please. Share with sound. Perfect. Let me know if you cannot hear it.
I would say that LaTeX is
It's good.
probably the gold standard for formatting, in part because like sighted people use it too for some
Ah,
things. So actually here there are even some math classes. I haven't taken one, but there are some math classes here at Harvard where you're required to enter LaTeX and like just raw LaTeX and submit that as your assignment. And here you have some classes you have the option to do that. And so some people will do their work in like Overleaf or something, which is a LaTeX editor. But usually I stick to doing everything in Word and then converting it to look pretty for
All right. Thanks to Campbell for participating in our panel this year. So let's talk about what even is LaTeX. And talking about it a bit, we're going to talk about it a lot more. LaTeX is a word processing system. So scholars and people use LaTeX to format papers, especially because of the ability to format math equations that look very nice when you print them. Today, we're going to explore it as a format for writing digital math equations. So why should we use LaTeX as a digital math option? It can be read linearly in English. It can be read and written by sighted and blind people. A blind student can show their materials to their teachers or classmates without any need for translating between Braille and text. And LaTeX can be written in Microsoft Word, HTML, and other accessible word editors. It can also get transcribed much faster, often on campus, than Braille can get printed. Often, STEM professors and students already use LaTeX for their class notes, so you can just pick it up and keep going. You don't have to get it translated. And there are many online resources for learning LaTeX, so you can just pick it up yourself and learn it if you want. You can write in LaTeX and then convert it to MathML for display and easier navigability. I'll talk a bit more about what that means. So what does LaTeX look like? For example, if we want to represent the equation y equals square root of x plus 3, then we can write that in LaTeX as y equals backslash sqrt left brace x plus 3 right brace. Backslash sqrt is a symbol that tells the computer to make the square root symbol with the little like line above the radicand. And then the left and right curly braces enclose the expression, which is x plus 3, that belongs inside of the square root. And then on the right, you can see this formatted equation. It's y equals the square root of x plus 3 with the line above it. So LaTeX, you write this code and then word processors like Microsoft Word or HTML, the browser, turns that code into a pretty formatted math equation that is also navigable with a screen reader. How does this conversion from LaTeX to MathML happen on a web browser? We're going to talk about that in our workshop today. We use something called MathJax. So what is MathJax? It's an open source JavaScript display engine for digital math, specifically LaTeX, MathML, and ASCII math notation that works in all modern browsers. It renders math equations as text rather than images, so they are searchable and navigable. And don't worry, you don't have to know about the inner workings of MathJax. All we do is like import it one time at the top of the HTML, and then it does all the work for us. It's really cool. MathJax also includes the ability to generate speakable text versions of math expressions that can be used with screen readers. And there's this assistive support in MathJax that also includes an interactive expression explorer that helps users to like walk through an expression one piece at a time. And it turns out that both the LaTeX and formatted equation can be accessed with a screen reader. Next, what does reading LaTeX and MathML formatted equations look like? I'll show you a video where a screen reader user reads a LaTeX formula in HTML and then navigates the MathML equation on the web browser.
$x equals backslash frac left brace dash b backslash pm backslash sqrt left brace b caret 2 dash 4 ac right brace left brace 2 a right brace $. Clickable x equals the fraction with numerator negative b plus or minus the square root of b squared minus 4 a c and denominator 2 a comma. Math.
Great. And then you said you can
That's
navigate
good.
the
Yeah,
different
let's see.
components of the equation.
X equals the X equals the fraction with numerator negative b plus or minus the square root of b squared minus 4ac and denominator 2a. Numerator negative b plus or minus denominator 2a.
All right, we got the gist. So you might be thinking that this looks a little scary. To represent even a simple equation, there are many characters and symbols that you need to use to format it. How will I remember how to do this? Don't worry. In this workshop, we'll demystify LaTeX so you can write equations yourself. And plus, even I don't remember a lot of the symbols, and often I have to look up how to represent these symbols, and there's lots of resources online. All right, tutorial time. Now we're going to try to write some LaTeX equations in HTML ourselves. So we've sent some instructions out this week with what to do. So we're going to open up the HTML file in a code editor and the web browser side by side on my screen. To open in a code editor, you can right click on the HTML file that you downloaded and select Open With, then click on your code editor application. I'll be using Visual Studio Code. To open the HTML file on your web browser, double click on the HTML file. And then you should have downloaded the style.css file. You can ignore it, don't open it. It just downloads and makes the web page look pretty. All right, I will do it myself.
I was going to say, Isabella, there's some questions on the
Oh, great.
chat. I don't know if you want to go over those before you.
That sounds good.
Do you want me to
Are
read?
are there any OER textbooks using LaTeX? What's an OER textbook? I'm not sure what that is. But a lot of textbooks are actually written by authors in a LaTeX file. So some of the students that we talked to actually have reached out to authors of their like math and computer science textbooks that they use. They've reached out to authors themselves and asked for like the source files of the textbooks, and they had to sign like an NDA or something, like a I will not share this file with people because that is like the source of a textbook. But then they just received the entire textbook in a LaTeX file, which is really cool. And then open educational resource. I am not sure if open educational resource textbooks use LaTeX, but they might. Not 100% sure. I haven't looked into it. That's a good question. And then another question was, are there tools to convert LaTeX to Nemeth to view on a Braille display or emboss? I'll show you in a bit. And by the way, LaTeX, I say LaTeX, but people also call it LaTeX. No one knows how to say it. You can call it whatever you want.
Isabella, I will comment that I did some quick searching. So open educational resources are books that are open sourced for educational purposes. And on a quick search that says yes, many open OER textbooks are using LaTeX format. So yes.
Thank you so much for doing that. That's awesome to hear. Yeah, like a lot of textbooks are actually being put out in LaTeX format. The issue that we've also seen with math and computer science for resources like textbooks and stuff in classrooms are often they're like in a PDF, and that's not accessible, right, by anybody with a screen reader or a Braille display. And so the cool thing about LaTeX is that a student can take these inaccessible PDFs and take it to the campus disability office, and they can transcribe it into LaTeX pretty quickly, whereas a lot of campuses don't have Braille printers. And if you want a Braille version, you have to get it printed off campus by a third party and then have it mailed, and that might take a really long time. So that's why LaTeX is a potentially good option to get like PDFs of assignments, textbook chapters, like quickly transcribed by your campus. If you can't get the whole LaTeX textbook, there's also assignments and exams and stuff to get transcribed too. All right. Let's start the tutorial time. So I'm gonna close this. I have in my I have my like file browser open on the screen. And so to open up the HTML file that I've downloaded, you right click on the HTML file and you go to open with, and then you select some code editor. I use Visual Studio Code. There's also Xcode. But yeah, select a code editor of choice, right click on it, and then to open it in a browser, just double click on it and it'll open up on a web browser of choice. I'm using Safari today. And if you need dark mode, there's a button that you can click for dark mode. I'm going to just present it in light mode for accessibility. You can do that. All right, I will continue. So some of the stuff that I talked about in the slides is included at the top of this web page. So I'm going to take us down to the LaTeX activity on the web page. So we see some boxes on the screen with examples of some things that we're going to learn how to write. And maybe I'll also show what the code looks like. So at the very top in the header, I was talking about MathJax earlier. We can see that in the header, I just included on line 8 this script that just gets the source of MathJax. And just putting this script thing, it just tells the HTML file, hey, I want to use MathJax to format my math equations. And then later in the HTML file, we just write some LaTeX in the way that I'm going to show you, and it's just going to make some pretty looking math equations. So let's try the first example. Let me make this smaller. All right. So to write math in HTML, we surround that math expression that I showed earlier in a double set of dollar signs. So for example, dollar, dollar, and then you put a math expression and then another dollar, dollar. And this way the browser knows that we're going to render math on the browser. Let's go to the first example. So I'm scrolling down to line 177. This is where the first example that we're going to write is. So we're going to write the following short math equation, y equals x squared plus 3. And to write this equation, we're going to need some symbols. For example, the caret, the up caret, that's for making an exponent. We need the equal sign for equals, the plus sign is for the plus, and the dash is for minus. So let's replace the current equation. On line 179, there you will see a dollar, dollar, and y equals 1 plus 2 dollar, dollar. So go to line 179 and replace that with y equals x squared plus 3. I'll give you some time to try it yourselves. All right, everyone's had a chance to try it. I'm going to write it myself for you all. So to replace the y equals 1 plus 2 with y equals x squared plus 3, I'm going to delete the 1 plus 2. And I'm going to write y equals x caret 2, and then plus, and then 3. So now to show this equation that we've written in the web, we save the file. I just did like Command or Control S, or you can go to File, Save this, and then we reload the web page. So now that we've reloaded it, the equation appears as y equals x squared plus 3, and it's very beautiful. And one cool thing about MathJax is that we can click around it. So here, I'm going to click on the equation, and I've had it set up so that it shows the caption of what the screen reader would read out loud. So it says y equals x squared plus 3. And you can also click the different components of the equation. So I have clicked x squared plus 3, or just the plus, or just the 3. And you can right click on this element on the web, and you can show it as the math equation in different formats. So you can show this as MathML code. Look how ugly this is. It's technically XML. This is what's in the back end, like the code that's rendering it. So we just wrote LaTeX in a really easy to write way on the left in the code editor. And then it converts into this crazy looking MathML format. And then it displays very beautifully. That's the power of MathJax. And we can also show the math as LaTeX commands. So if you ever see like this pretty math equation on the web, you can also see what the LaTeX is underneath. You can also show this text as Braille code on the screen. So it translated this LaTeX into Braille, which is pretty cool. You can also copy it to clipboard and put it somewhere. And you can also have it speak, but I'm not going to have it speak because it's going to be a lot of talking with me. But you can also turn on the captions. I think that's in speech settings. You can show subtitles. So I have that checked. You can also check auto voicing, so it'll always speak. But I have just show subtitles turned on. So then it shows this bar with the text on it. It's pretty cool. Let me know if you have any questions about that. We can talk more. We're going to have some time for Q&A after we do a couple of examples together. All right, let's try example 2. In example 2, we're going to talk about fractions. We need to learn some new syntax for writing fractions. Oh, and I'll voice this comment in the chat. Deborah says, the ability to speak the results of the code is helpful for low vision and learning disabled students who depend on audio and not Braille. Thank you for sharing that. That's awesome. All right, let's keep going with fractions. So we'll need this new symbol backslash frac, backslash FRAC. We need this to tell the computer we're starting a fraction. In LaTeX, there are many symbols that start with backslash, like square roots and fractions. After backslash frac, then we need some curly braces, and we use these to group the numerator separately from the denominator. For example, we'll write backslash frac, left brace, right brace, left brace, right brace. That'll create 2 groups for the numerator and the denominator. So in the code editor, let's go to line 206. And here, let's change the current fraction that's displayed, which is 1 over 2. Let's change that into a 3 over 4. And again, that's at line 206. Currently, we see on the screen backslash frac, left brace 1, right brace, left brace 2, right brace. Change that into a 3 over 4 fraction. I'll give you some time to try it yourself. All right. Now I'll write it for you all. So on line 206, I'm going to replace the 1 and the 2 with a 3 and the 4. So it's going to read out backslash FRAC, left brace 3, right brace, left brace 4, right brace. Now I'm going to save the file again. Or remember, that's file, save, or command or control S. And then I'm going to reload the web browser. Great. Now we've seen that the equation in example 2 changed to a 3 over 4, and the screen reader would read out 3/4. which is cool when I click on the MathML equation. And what's interesting is that when you click on the different components, it doesn't just read out 3, it reads out numerator 3, and then it also reads out the denominator 4, which is pretty cool because we formatted it as a fraction. The computer knows that like this number is in a fraction. It's not just a floating number. All right. Let's try. By the way, we're building up to writing a more complicated equation. You guys saw in the demo earlier that the screen reader user demo was doing the quadratic formula. We're building up to being able to write that. That's pretty exciting to me. So that's why we're introducing some of these different elements that you would often see in lots of equations. We're learning them for the quadratic formula today. So next, let's try example 3, which is square root. The square root symbol, which I showed earlier, is \sqrt. So in example 3, let's write the square root of x plus 3. And don't forget the curly braces that enclose the whole square root. So in example 3, on line 236, I invite you to replace the current equation, which is \square root sqrt of x. Replace that with x squared plus 3 inside of the square root. I'll give you a chance to do that yourself. And feel free, if you have questions, to put them in the chat. I can help anyone who has issues with anything. All right, I will show you guys how to do it. So on line 236, I'm going to replace the equation \sqrt left brace x right brace with x squared plus 3. So I'm going to write x inside of the square root curly braces. I'm going to write x caret 2 plus 3. And then I'm going to save my file and then reload the web browser. And in the example 3 box, we should now see a square root symbol with x squared plus 3 inside. Whew. And that reads out the square root of x squared plus 3. Woohoo. And if we click on just the x squared plus 3, this is read out by the screen reader, radicand x squared plus 3. So that's how we know that the expression is correctly enclosed inside of the square root. All right, we have a question in the chat. When this source is printed rather than appearing on a browser page, does it then become graphics? By graphics, do you mean like a tactile graphic or like just like an image? Because when you print this, yeah, like if you printed it, it's just going to print as is, like an image. Like, for example, a lot of people that we've talked to write this LaTeX inside of Microsoft Word, and then some people, they write LaTeX in Microsoft Word, and then it converts into this MathML format. And then Microsoft Word, when you convert it to PDF, the newer versions of PDF, like PDF 2.0, they embed MathML into the PDF. And so Microsoft, if you export it with accessibility, which is an option, it should make the PDF accessible, which is pretty cool. But if you just printed this web page to PDF, I have not tested if it embeds the MathML. I don't know, probably not. But if you do it with Microsoft Word, yes. And a lot of some of the TVIs that we've been talking to that we're telling them about LaTeX, they already use Microsoft Word, so it's like it's a good way to write LaTeX math equations because it also includes accessibility. I hope that answers your question. But yeah, today in this workshop, since it's a coding symposium, we wanted to show how to do like LaTeX math equations in HTML and showing it on the web browser, but this is not the ideal setup for printing or for distributing PDFs. The ideal for PDFs would probably be Microsoft Word. And in a future, my future work, actually, I am creating a professional development tool for teachers of visually impaired students for them to learn LaTeX. And it's going to be web-based, but we're also going to have a component where we include Microsoft Word documents so that teachers can transition into using LaTeX from on the web into using it in Word for their students and tracking their learning. So definitely keep in contact with me. If you're interested, share your email with me or yeah, email. I'll show some contact information on the last slide, but if you want to keep talking about LaTeX with your with how you can learn it and interact with LaTeX with your students, let me know. I'll talk more later as well. But yeah, any other questions? One question in the chat is, does Word natively support LaTeX now, or do you need a third-party tool like MathType? That is a good question. I think it currently supports LaTeX natively. I can just write LaTeX into Microsoft Word in the math equation editor tools, and it works totally fine. I don't have a third-party tool like MathType, so I think it's natively supported now, which is pretty exciting. You're very welcome. All right. Let's continue with the workshop. More Q&A time later. All right, we just did example 3. We wrote a square root. Let's try, we have two more examples left. Example 4, we're going to try putting the square root inside of a fraction. So we're going to nest the components. So what happens when you want to put an expression inside of an expression? We need to nest them. We can nest LaTeX math expressions by putting curly braces inside of a set of curly braces. For example, if we wanted to nest expression 2 inside of expression 1, we would write the following: left brace, expression 1, and then left brace, expression 2, right brace, right brace. So in that way, there's one set of curly braces with one expression inside of another expression. Let's try this out by putting a square root inside of a fraction. So let's convert 1/2 to the fraction of, with numerator, square root of x squared plus 3 that we just wrote, and denominator 2a. So on line 273 is where we're going to write our equation. So currently we have the backslash frac, left brace 1, right brace, left brace 2, right brace. And then here, let's replace the numerator and the denominator with a square root and the 2a. I'll give you guys a minute to try that yourselves. Let me know if you have questions. All right, it's been a minute. I'm going to write it for you all, the equation. So on line 273, I'm going to replace the first set, the 1, in the numerator, curly braces, and I'm going to write backslash SQRT, left brace, and then my code editor automatically put a right brace. And inside of this square root, I'm going to write x caret 2 plus 3. And then in the denominator where the 2 is, I'm going to delete the 2, and I'm going to write 2a. So the LaTeX expression currently reads backslash frac, left brace, backslash SQRT, left brace, x caret 2 plus 3, right brace, left brace, 2a, right brace. I'm going to save this file, and I'm going to reload the web browser. Woohoo! We have an equation. When I click on it, the equation on the web browser, the caption says the fraction with numerator the square root of x squared plus 3 and denominator 2a. So that means that we correctly formatted the equation. Great. And you can click on the different components. Now we can see that it says numerator the square root of x squared plus 3 and denominator 2a, which is pretty exciting. All right. Now that we've done all of these different elements, let's try to write the quadratic equation in example 5. We can put everything that we've learned so far together. And don't worry if you don't know what this equation means. We don't need to know what it means to write the math equation in LaTeX. All right. In example 5, on line 303, I've left it blank. It just says x equals. So I'm going to invite you all to try to write the following equation with LaTeX. We have everything that we already know. Sorry, let me rephrase that. We know how to write all these different pieces together, so now we just need to combine it in a new way. And we do need one new symbol though. Backslash PM is how you write the plus or minus symbol. So the equation we're going to write is x equals numerator negative b plus or minus square root of b squared minus 4ac, and then denominator 2a. So I'll give you a minute or two to try it yourselves on line 303. All right, has everyone had a chance to write it? Let me know if you need some more time in the chat. Or if we're good to move on, I can write it for you all. Oh, also in the chat, someone wrote, Ben wrote, as a math person, I love this. This reminds me of learning how to input equations into a TI-87 in finance, and then heart eye emojis. And I thought that was really awesome. But anyway, let me write the quadratic equation for you all in LaTeX. It's gonna look gnarly written out, but it's so nice when it's formatted. So to write this, we think about the different components that we need to build kind of like the skeleton of the equation, kind of like the structure first, and then we think about what the leaves are, or like the smaller bits, the details after we built the big structure. So for the quadratic formula, The bigger structure I see is a fraction. That's going to enclose different elements. So for the quadratic equation, I'm going to write x equals, and then I'm going to start with a fraction, backslash frac, left brace, right brace, left brace, right brace. In the first set of braces, the numerator, I'm going to write -b plus or minus, so that's backslash PM. And then inside of here is a square root, backslash SQRT, left brace, right brace. And in there, b squared minus 4ac can be written as b caret 2 minus 4ac. And that should be the whole numerator. And the denominator in the second set of braces for the fraction, I'm going to write 2a. So this should read out x equals backslash frac, left brace, -b, backslash PM, backslash SQRT, left brace, b caret 2, dash 4ac, right brace, right brace. That's the whole numerator. And then left brace 2a right brace is the denominator of the fraction. I'm going to save this file, reload my browser, and now we should see a formatted equation in example 5. The MathML reads out x equals the fraction with numerator -b plus or minus the square root of b squared minus 4ac and denominator 2a. So that means that we formatted it correctly. I know some of you might be thinking, wow, this looks gnarly. This LaTeX looks gnarly. When you read it out loud, it's a bunch of characters and symbols. What the heck? And I can agree with you. It's pretty gnarly, especially when you start to write some crazy looking equations, like really big ones. Um, but it's like people do get used to reading this with a screen reader. People do get used to it, and some students end up really enjoying it for their higher level math equations. So definitely start small. Don't start with the quadratic formula. Start with the smaller things like examples 1 through 3 that I showed you all, with just exponents and plus or minus and those kinds of things. And then we have a great formatted equation. But yeah, that's all of the examples I have for you today. In this web file, in the HTML file, I do also have at the bottom some other examples that you can try on in your own time. Like for example, I have some instructions on how to write an integral, which is a calculus formula. You can also write a limit. That's another calculus formula. Or you can even write something from statistics, probability statistics, called a normal distribution. Like this equation looks pretty gnarly. It has a fraction, it has new symbols like pi and sigma, it has an e with an exponent that has a fraction inside of the exponent. You can use everything that we've learned today to write these crazy equations on your own time if you're interested. And we also, oh yeah, you can also write a matrice, like in linear algebra. Or in algebra 2, I think we did matrices as well. So there's an example of how to write that as well in the HTML file. And at the bottom, I have some resources. But with that, I'm going to take us back to the slides and we will do some Q&A. Oh yeah, Q&A time. Anyone have questions about LaTeX math, about using this in computer science or STEM majors in college, how like teaching it, anything like that, or more about LaTeX HTML? Any questions? Feel free to ask.
Isabella, I think there was a question earlier
Mm-hmm.
about Braille displays,
Mm-hmm.
and I'm going to add to that by asking, um, because I think I know the answer, that this can, the LaTeX can be read in either UEB or Nemeth depending on your Braille display's settings. Is that correct? Or do you have to do settings within the web browser or something?
I think it's in the settings of the Braille display. So if you use a Braille display to read LaTeX, it'll just read out the like characters, I think, in whatever format the Braille display is in. And then on the web, it reads the like MathML formatted version in whatever like your Braille display is set up because it's just like text on the MathML on the web on like this side with the math formatted.
That
Um,
makes sense.
yeah. Yeah, so it's a pretty cool like teaching tool, I think, too, because then like students can explore it with a screen reader. They can also explore it with a Braille display. They can also explore it with like magnification. It's like different assistive technology can be used with different formats of math. I see another question in the chat. Have you had success asking an AI how to code something in LaTeX? And the answer is yes. Like ChatGPT, like those kinds of like chatbots, they are trained on everything on the web, right? And I said that there's a lot of resources about how to write um, like math equations in LaTeX on the web. And there's lots of resources on how to format things in LaTeX in general. So ChatGPT and things like that do know about LaTeX math. The thing that chatbots don't know yet, which we're exploring, is that LaTeX is accessible for blind screen reader users. So I've asked ChatGPT like this year, like what is LaTeX accessible? And it said no, which is wrong. That's the thing that we're hoping to challenge and we're hoping to encourage people to learn is that LaTeX is accessible. It just depends on like what platform you're writing LaTeX on. For example, in the demo, not the demo, in Campbell's quote video that I showed earlier, she said that some people use something called Overleaf. Overleaf is this platform for writing like science papers. I use it all the time for writing my conference papers. It's I don't know how accessible it is. It's not super accessible for screen reader users, especially when you need to like fix issues because it's like LaTeX is a code. So if you don't write the code properly, it'll break a PDF that you're trying to export. And also a lot of the times the PDF that's exported from Overleaf is not accessible. But LaTeX, the organization, is working on creating tagged PDFs, which is really exciting. So that's new development. Um, but LaTeX writing itself, like writing LaTeX math equations in Microsoft Word is accessible for screen reader users, which is really exciting. So one of the things that I've been working on is we're actually trying to create our own chatbot that knows about LaTeX and knows about accessibility and LaTeX and can direct people and work with different kinds of platforms. That's something I'm working on currently, but it's not done yet. We're hoping to show our final product at CTE VBI, the conference for teachers of the visually impaired and other staff that work with blind students. We're hoping to demo our like final product of like teaching LaTeX to teachers and that also includes a chatbot that knows about accessible LaTeX. Um, that's something we're currently building. So hopefully by like April, it'll be done. Hopefully that answers your question.
That's very exciting. And when you have that, please let me know and we will link it in the Hive.
Heck yeah, we definitely
Yeah,
want to spread the word when it's done and we want people to use it and to like learn about different accessible math options for their
awesome.
students.
Yep.
Yeah, definitely. Any other questions?
Um, so can you, is there any translator software or anything that
Mm.
will convert things to LaTeX?
Yeah, there is. If you search on like Google, like LaTeX to MathML or LaTeX to Braille, there are some resources that I've seen. I don't remember if I linked any. Let me see my slides. Yeah, yeah, I didn't link any, but that's a good question. Um, let's see. LaTeX, I'm gonna search on Google quickly, LaTeX to Braille conversion. So I see this LaTeX, the number two, LaTeX-to-Nemeth tool. Maybe this is something. No, this is a PDF. Never mind. I would have to look it up. That's a good question though. I
Yeah.
know they exist. Like I was using a converter to make some of the MathML for my HTML file. I know that like LaTeX to MathML exists. Um, I think this is one. Yeah, like this one is for converting LaTeX on the left, like square root of like 2, and then it outputs to MathML. This is temml.org, and you can display it in different formats. So like if you're using this for code, and you can just get the code in different ways here, but this doesn't convert it to Braille. But I do know that there are converters for LaTeX to Braille.
When I think if it's in MathML,
Mm-hmm. Yeah.
for a lot of Braille displays, it kind of
Yeah.
depends. But
Yeah. And
okay.
Microsoft Word will take a LaTeX and convert it to MathML too. So,
Yeah, that's right.
yeah.
You mentioned that earlier.
Yeah.
That's interesting.
And then somebody wrote Duxbury will read LaTeX. They use Scientific Notebook to create LaTeX for ducks. That's interesting. Um,
Yeah,
Scientific scientific notebook.
Scientific Notebook's been around for a minute. I was going to say, this is Jeff. I think one of our earlier conversations with Stacy and you, I was having a deja vu moment because I hadn't thought about LaTeX in a very long time, and I, of course, was calling it LaTeX, but it was the format that was the code that I was using back, I would say, in the mid '90s to create secondary math. Well, math at the community college. It was using Scientific Notebook to mark up text for LaTeX to be able to easily convert into Nemeth at that time. One of the exciting things that I have been thinking about ever since our first conversation and being involved in some of the math groups around the country is currently in America, we have two different math codes simultaneously trying to be supported in across the country, and it varies from state to state. And even within some states, they have either Nemeth or UEB technical. And as we were talking further about students pursuing computer science or higher level math, how do we bridge that gap or avoid putting our students at a disadvantage as we kind of sort through or figure out the path forward in supporting students in math? And LaTeX seems to be a really great middle ground. And I think whenever we can access standard code that is being used broadly and widely when it is accessible as is for students who have different learning abilities, I think we're doing a great service. And so perhaps this can be something that's infused into future conversations because I don't think there's any reason to be debating between Nemeth and UEB, but what we definitely need is solutions for students who are wanting to pursue computer sciences, coding, and mathematics. And it seems like this might be an excellent compromise because it's not new, it's a standard. And whenever
mhm.
there's a standard already in place that's accessible, I think this has some great potential moving forward. I think it's just more getting the great word out.
Yeah, and that's going to be our work this year for sure, is trying to get some more word out. I totally agree. One of the things that I can say to add to that is like we see LabTech math equations as like another tool in the toolbox, like adding to Nemeth. We're not trying to replace
Right.
Braille. We think Braille is extremely important for math learning, especially in K-12. The thing that we've been learning is that when a student goes to college and they need their Braille, they've been using it this whole time, that the math equations get exponentially harder. They have so many more symbols and they're so obscure. And there isn't really a standard, I don't think, for some of these symbols. And you have to like obtain like a textbook for just learning how to write and read these new symbols for Nemeth. And they're not easy to find resources online. And what's cool about LaTeX is that it is a standard. There's so many resources online about how to write math equations in LaTeX, from like simple equations like y equals x plus 2, all the way to like insane looking physics equations. You can represent them with basic LaTeX knowledge, like the backslash frac. Like you're going to see that everywhere for large equations. So it's just another tool in the toolbox for sure.
There was a
Well,
question in the chat from
Hmm.
Peter that said, when writing out the steps to solve an equation, each line needs to be separated and wrapped by the by $ symbols. You can simply press enter to start a new line. That's a question.
That's a good question. So let's try it now. I'm going to just put a couple new lines inside of the double $signs, and I'm going to put like an x equals to 3, save it, and I'm going to see what shows up. Okay, so the double $signs, I think you can only put one equation in this line because when I tried to put an x squared x equals 3 on like a new line, it just puts it right next to the equation as if it was like inside the equation. So it reads out like the whole quadratic equation, and then right after denominator 2a, x equals 3. Like it just keeps going. So put one equation inside of each like LaTeX container, maybe is a good way to put it. The double $signs are kind of like a container for like one math equation. So if we want to put another equation right underneath the quadratic equation, I'll just put another set of $signs. I think you can put it inside of the same div in HTML. So let's try this. So now each of the quadratic equation is inside of one container, and then now x equals 3 is inside of another set of $signs. So I'm going to save my file and reload it. So now on the screen on the web browser that I've reloaded, on one line is the quadratic equation as one formula, and on a new line underneath is x equals 3 as a separate equation. And there are ways to format this in like inline. You don't have to make the equation look like it's just one equation on one whole line. I just didn't put that in the presentation today because we wanted to leave time for questions and stuff. But instead of double $signs, you change the double dollars into like, I think it's backslash parenthesis. You can look up more information about how to format for web. But yeah, you definitely do need one container for each math equation. That's a really good question. Same within Microsoft Word. I think you don't use the same method of writing, but in Microsoft Word, when you're entering one equation, you enter the equation and then you like hit enter or something, and then it formats into one equation, and you would need to start a new equation to enter another equation. So it's kind of like that, thinking about what containers mean for math equations in web. It's kind of similar to Microsoft Word, I think.
I have to give a shout out to Stephanie put in the chat that Braille Blaster will also read LaTeX. So we have a lot of tools available to us already that can handle this code. It's just I don't think we're having the right conversations. So
Tactile view also allows for it. So
yes, that's true.
it's out there.
Yeah.
It in a lot of places.
Yeah, I think it's bringing this conversation into our community more and getting more buy-in and more input on its usefulness and just I think it's time to reintroduce the conversation is what's happening. So
Yeah, definitely. How much time do we have left? Do we have like a few minutes left in our presentation?
Yeah,
3 minutes, yes. Got a few minutes.
Okay. I have some like closing thoughts I can do after this Q&A slide. So I just have a little bit of text about like what does this have to do with computational thinking. I don't have to go into it that much, but like we did think a lot about like logical ordering of different components. So like if you introduced this LaTeX idea into like a computer science class, it does help students like learn how to organize ideas you learn syntax, like you use curly braces, you use parentheses. So you're kind of getting the student like thinking about computers, which is kind of cool. It's not just an accessible math writing tool. You can also use it to teach a little bit of computer skills. You could even use it as like in the web. It can be like a little like tutorial of like how to write in the web also. You can kind of combine different ideas. But in conclusion, why should we learn LaTeX math? We've been talking about it for the past few minutes, but I want to reiterate it's a useful and accessible option to read and write math equations across various kinds of math, from algebra to calculus and beyond. It's accessible to read and write with a screen reader with Braille displays, as we've talked about. And LaTeX can help blind students and college STEM majors access their course materials faster than a Braille printed out tactile material can get sometimes. Some large campuses do have on-campus Braille printers, so that's super lucky, but not all students will have access to something like that. So it's really important to increase the tools that students have access to so that they can access their materials in different formats as they need. And LaTeX can be applied in physics. It can be used in chemistry, computer science, and many other STEM fields. So it's not just for math, it's for many kinds of STEM, which is really exciting. On the slides, I have some resources just about like what is LaTeX, what is MathJax. Feel free to check them out. I've also put a couple of slides about our outreach from my lab at UC Irvine. The past 2 years, we've put on an Accessing STEM in Higher Education event for local blind and low vision students and their TVIs and other like assistive technology specialists and anybody local to us to come in person. And we also do hybrid. So we have people join via Zoom. This past year in April, or I think it was in May. In May, we talked about like math, digital math, and that's where we got Campbell on a panel to talk about accessible math and how she uses LaTeX in her classes in her math major. We have a link to the whole video if you're interested in learning more about how college students who are blind or low vision access their math and what kinds of tech they use. Feel free to watch this video. It's a few hours long, but there's transcript. You can skip things. There's also a couple links to blog posts about the first event in 2024 and also the latest one in 2025. I put links to those. And also put a little bit about my research. I wrote like a paper about putting on that event so that we can start having conversations with the computing education research community to try to encourage them to put on accessible STEM events like this, like our outreach event. So you can feel free to download the paper and read it. It has in like it's kind of like a how to put on an accessible event and why it like helped people. So feel free to download that. And with that, thank you so much. This has been amazing. Thank you for participating and asking all your questions.
Thank you so much, Isabella. This was very interesting. It's hard to get enthusiastic about math sometimes, but
Yep.
you definitely brought it.
Thank you.
So,
Yeah, thank you so much. And please feel free to reach out. I'm Isabella. My colleague Josa is here, and I put my email on the slides. My professor, Dr. Stacy Brenham, her email on the slides. And we also have an email called access-uci@uci.edu. We're going to start doing more outreach with that email, so please feel free to reach out if you want to keep working with us, learn more about LaTeX and accessibility. Yeah, that's it. Thank you.
awesome. Thank you so
Wonderful.
much.
Thank you. I really, I don't know, I haven't been this excited about math in general in a while, and it has really just reinvigorated my interest in this, and especially, like I said, with some of the challenges posed with making sure our students are included in all the conversations around mathematics. I think this might be just one more key to assuring that the conversation isn't bypassed by folks who need to be involved in the conversation. So thank you.
I love that. Thanks. Thanks, everyone.